think we'll get started with the diagnosing queen section. I'm not sure if you have any questions in the Q&A. I don't think so.
Hey Garrett, there were a couple that I answered that I said that maybe you could expand upon
Sure.
because I wasn't sure 100% if that was your frame of thinking. Monica was asking when with the difference between the honey location and the queen loss and queen right colony, with your honey frame for
Mhm.
your not queen loss, queenless. Um, Your honey frame in the queenless colony is really close to all your other frames, where your queen right colony, it's on the outside of the box, like the last frame of the box.
Yeah, I think so. So one reason I did that was because I'm basically gonna split that into a four frame nook, and so you can definitely move that honey frame out farther wherever your frame feeder is or whatever feeding method you have, and so have I guess those empty frames in between your honey frame and your brood. But there's really not a wrong way of doing it. And so I think for that picture, I just had where I move it to different locations. So kind of depends. There's really not a wrong way to do it, to be quite honest. And and sometimes I do typically put them like right in the middle, but you can put them near the frame feeder. But the one thing you don't want to do is have those brood frames spread out from each other. So you want to make sure that they're all, within like right next to each other. So those bees are kind of helping each other out and raising the brood.
Okay, and then Ski asked if you use a five frame nuke on top in your four frame example, do you just add another empty frame?
So out of yeah, so typically the five frame nooks are too large to go on top, so you need the four frame nooks. So the ones that only fit four frames. Because most nooks that you purchase are gonna be the five frames, so they fit five frames in them. And so if you use a five frame nook on top, so you're saying if you add a queen excluder and then one five framer on top, do you add
Yeah, I
another
think
empty
that's
frame?
yeah, I think that's
Yeah,
what he
yeah,
was
I
asking.
would. Yeah, it kind of depends on, I guess, how big you want it. And so if I'm only making two frame nooks, so let's say I have as many brood in there, I'll add extra empty frames in there, especially if I'm using a mated queen because she'll need more space to lay. Um, but yeah, if I make a three frame nook, I'll basically have three frames of brood, one empty frame, and then one frame of kind of honey and pollen resources. So it kind of depends on how big you want to make your nook. Okay, I think that's all of them, right, Heather?
Yeah.
Okay. And like I said, there's not really a wrong way of doing it. There's different ways of doing it. So, you can definitely add more frames. You just want to make sure that there's young brood, some cap brood, and a frame of honey. So you can make them smaller or larger depending on how many resources in the colony or how big you want to make the nook. Okay, so now we'll get to the second part of, kind of importance of queens. So I know I talked about this a little bit more in the biology section, but queens are something to be really important once you get into the queen rearing and breeding section of this. And so queens are really important for the colony. And a lot of you are experienced beekeepers who have at least one year of experience, probably a lot more. And so you guys really understand the importance of having a good, high quality queen because she's the only one that's laying eggs, reproducing within the colony, and if something happens to that queen, that could definitely have a huge impact on your colony. So think about a honeybee colony, right? We typically have one queen in a colony. I've seen some situations where I've had multiple queens in the colony. I know we have a setup here to raise two queen systems, but typically you have one queen in the colony. She's typically quite a bit larger. She has these kind of huge developed ovaries that allow her to lay, thousands of eggs per day during the peak summer months. And so the queens are really important. We have the drones, and so drones are really important for queen quality also because if the queens are flying and mating with high quality drones and more drones, that's going to directly impact your queen quality. And so queens and drones interact really closely together. Now the problem for beekeepers is, they're flying in 3 mile radius trying to find each other, and the queens are mating with 15 to 20 random drones, and so The drone part of it, the male part of it, is nearly impossible to control unless you're doing some sort of instrumental insemination or artificial insemination. But the one thing you can control as beekeepers is the queen. So, if you raise your own queens, you can control the quality of the queen, you can control her environment to some extent, and you can make sure that she's mated properly. And so, even though drones are you have less control, the one thing you do have control of is the queens. So it's about colony losses. We think about 50% loss each year, and majority of these are due to the Varroa and viruses, but typically queen failure and queen quality rank among third colony losses really over the past 15 years. And so it's a really big issue that a lot of beekeepers face, especially here in Texas. And so we know that queens used to live 3 to 4 years, and even some reports up to 7 years, but now queens are failing at a higher rate. Now, why are queens failing? It could be a mating issue, so the drones that the queen's mating with, but could be due to more viruses in the colony, more varroa in the colony, more exposure to pesticides, poor nutrition, and so all these things interact together that could directly impact queens. And so we're still not quite sure what causes queen failure. It's probably a lot of different reasons, but something that most beekeepers have to deal with at some point. But most beekeepers really want your queens to live at least a couple years if possible. But you may have a situation where you're either raising your own queen or purchasing a queen and they fail within 6 months, and that leaves you in a tough situation to try to replace that queen and get a new queen in the colony. So why are queens important? I think we all know some of these reasons. I'd say for me, the most important part of a queen is the genetics. And so last week we talked about a lot about colony genetics and how the queens contribute about 50% of the genetics within the colony. And so you think about all these traits that we want to see as beekeepers, right? We want less aggressive colonies. We want colonies that produce a lot of honey. We want colonies that have at least some resistance to varroa and viruses. And so a lot of these traits that we see are directly influenced by the genetics of the queen. And we know, and I actually went to Man Lake last week and looked at all the queens they have available, and it's really hard to find which queens to purchase and why to purchase them. And so you can go online, you can find Italian queens, Carniolan hybrids, you can find Russian, Saskatraz. So there's definitely a lot of different options available. But for you, depending on how many colonies you have, you can purchase queens from different sources and see which ones perform the best in your area. And so maybe the Russian queens or the Saskatraz queens do better in your region. And then over time, as you're basically selecting or grafting your own queens, you can have queens that are more locally adapted and perform better in your specific area. And so maybe initially when you're purchasing your queens, may not have the desirable genetics or the best genetics you're looking for, but over time, if you have some sort of selection program, you have queens that are more suited to your specific area. And maybe if you're collecting swarms or doing bee removals, those could have desirable genetics depending on how long they're living in that location. And so sometimes during bee removals, bees have lived there for multiple years. And so they know that you sort of know that they're a bit more resilient and maybe more tolerant to the Texas weather versus a queen that you purchased from maybe, Florida or California or even parts of Texas. And so for me, I think the most important part of a queen is genetics because it influences everything related to the queen and the colony traits that you want as a beekeeper. Second, we look at the egg laying rate. And so what you really want to do is you want to have a queen that, lays a lot of eggs and allows the colony to grow, survive, and more importantly, reproduce. And so egg laying is a really important feature of the queen. And we do know if you have a younger queen that she can lay a lot more eggs and she's more willing to have a more solid brood pattern. And so that's one reason why beekeepers typically replace their queens every single year because they're trying to get a younger queen in the colony that's laying, more in eggs. And so egg laying is a really important part of the queen. And we also know that there's some variation between these different genetic lines. So if you buy an Italian, Russian, so on, we always use the term 2,000 eggs per day, but it kind of depends on the queen and the weather and other factors like that. Sperm storage. So after these mating flights, the queen will basically store the sperm from those males into the sperm storage organ called the spermatheca. And then when she's done with the mating flights, she'll use that sperm that she stored over the next, years or so to lay these unfertilized eggs that become either workers or maybe potentially future queens. Now, a queen, they produce these very specific antioxidants and proteins in that spermatheca that allow them to keep that sperm alive. So these proteins are basically feeding that sperm. They're making sure that the sperm's not stressed out and allowing that sperm to live longer periods of time. Now, if that queen's really stressed out, that could impact the proteins, the antioxidants that she's producing, and could lead to lower ability to store that sperm. Now, as beekeepers, there's not much you can do about that other than reducing the stress of your colony, reducing your exposure to agrochemicals, improving colony nutrition. But sperm storage and ability for queen to store sperm is really important because if something happens during the sperm storage, that could cause a queen to fail within a few months when they should be reproducing for maybe multiple years. And they've got colony traits, and so colony genetics and traits kind of go hand in hand because if the queen has the right genetics and has the genetics that influence the traits that you want as a beekeeper, that's going to influence the traits that you're seeing. So maybe you want more less aggressive colonies, more mite resistant colonies. This is typically influenced by the genetics that the queen has. And like I mentioned, it's really hard to know the genetic line or background of your queens. I mean, a lot of times they're just basically mutts. But if you do have a high quality queen and this colony is performing really well, it could be a good idea to graft from that colony to make sure you're passing on those really great genetics you're looking for onto the next generation. And then more importantly, the pheromones. So these pheromones influence everything related to the colony. So we have pheromones that one tell the whole colony that there's an active laying high quality queen within the colony. And so this is called the queen mandibular pheromone. And basically the workers are grooming the queen, taking that pheromone and spreading it throughout the colony. So that tells the bees, even though they may be, 3 boxes away, that there's still a queen in the colony and they can focus more on, collecting resources and pollen and nectar that the colony needs to, raise that brood and really have high quality workers. There are other pheromones that the queen lays. So when she lays an egg, she adds an egg marking pheromone. This is really important for basically telling the workers that, hey, we have a lot of eggs in the colony. We need, pollen and nectar to support this egg hatching and then larva growth development. And so these pheromones are extremely important. One thing we do know is, younger queens produce, I guess, higher quality and more pheromones versus an older queen. And so in a situation where queen starts failing, starts getting older, these pheromones typically wear off, and that really signals to the workers that they may need to replace that queen and add a new, higher quality queen within the colony. So, you can definitely requeen every single year, or you can requeen after multiple years. Just know that there's more risk involved if you keep an older queen because they're going to lay less eggs, they produce less pheromones, and there's potential that she might fail or run out of sperm at some point. So, there is some risk involved with having older queens, but sometimes it's very hard to replace those old queens. So if you've ever done a split before and you have a really nice queen, it's really hard to replace that queen. So I totally understand. So if you want to keep that queen and see how long it'll live, maybe graft off it the next year, you can definitely try that. So the typical life cycle of a queen can be somewhere up to 1 to 4 years. So I mean, even reports show that some queens can live 7 years. If you go back to the 70s and 80s. Now I'm not sure how reliable that was, but the beekeepers say it's true, so it must be. So queen development occurs during a 16-day period. So, like you mentioned in the first lecture, workers take 21 days to develop from an egg to an adult, drones 24 days, but then the queens are 16 days. And so they have this rapid growth. So even though queens are quite a bit larger than a drone or a worker, they develop really fast and develop in a larger way. But this point is really important because this is when the queens are developing these large ovaries. And so the queens have two ovaries and about 100 or so ovarials per ovary. And these ovarials are where the eggs are actually produced when the queen begins laying eggs. And so for a worker, the workers are female, so they have ovaries too, but they're typically shriveled up. And so this developmental stage for queens is really important for this ovary development and also the spermatheca, which is where the queen's storing the sperm. After the queen emerges as adults, probably after a week, maybe 5 days to a week, the queen will fly out, go on these multiple mating flights, and mate with males. After these mating flights, the sperm will migrate through the oviduct into the spermatheca, and the queen will store that sperm. Then after that, typically the queen will never leave the colony again. There are some situations where the queen may leave the colony due to swarming or absconding, but in most situations, the queen will stay in the colony and never leave the colony again. And so that's why it's really important in this mating and her ability to store that sperm because she's storing that sperm to lay these thousands of eggs per day. And so this egg laying is really largely influenced by one, the number of drones that she's mating with, and also two, her ability to store that sperm. So if the queen's mating with less males, then she has less sperm available to lay fertilized eggs. Or if she really can't store that sperm properly, that sperm could slowly die over time and cause her to lay, unfertilized eggs that become males. And so that's where you start seeing some of these queen failure rates. So during development, I know this picture is drawn. I'm hoping to get some hand-drawn pictures of queens, but I mean the development's pretty much exactly the same as drones, except they don't develop testes, right? They develop ovaries instead. But the concept is really the same. So, like I mentioned, the first two lectures is, honeybees are holometabolists. So they transition from kind of these large digestive tissues all the way into what we'll have to see as an adult bee. Now, during the larval stage, this is when the queens develop these large ovaries with the hundreds of ovarioles, and that allows the queens to lay, these thousands of eggs per day. They go through metamorphosis, and so they spin a cocoon, and then once they emerge from metamorphosis, they become really, really a pupa queen. And so, by at this point, they have the ovaries, the guts, and all the reproductive tissues needed to lay eggs. And so, I mean, really the most important part of the queen is this larval stage. And, workers are really good at taking care of the queens. And so typically during development, you don't see a lot of issues with the queens. But if you have a high mite load, you may see a few mites in your queens. I've only seen them once, but that colony was out of control. So if you see diseases and things with the queen, that's a pretty good sign that there's some larger issues within the entire colony. So, like I said, I think last week or maybe the first lecture, we talked about caste determination. So, caste determination basically means that you have a fertilized egg, and this fertilized egg has a potential to either become a highly reproductive, specialized reproductive queen, whereas the one female can also become a non-reproductive worker that's specialized in nursing, foraging, guarding, and all these important tasks within the colony. And so, queens and workers are genetically exactly the same. But based on the food and the nutrients they receive during development, these workers have the potential to become either a queen or a worker. So if a queen lays an unfertilized egg, or a fertilized egg, I mean, this fertilized egg is a female and has the potential to either become a queen or a worker. Now, during development, basically, if a colony needs a new queen, they say, okay, this larva needs to become a queen. So they feed them more food and different resources. And so in a situation when the larvae are less than 3 days old, at least, and they want a queen, they'll make this cell a lot larger into what we like to call a queen cell. Cells are kind of really long, kind of a peanut shape, versus the worker cell is what we like to see in the typical wax comb. And so really the food differences between queen cell and worker cell are pretty much exactly the same. But the only difference is the queen cell is receiving a lot more food and a lot more nutrients. So for example, queen cell will receive about 360 microliters versus about 160 microliters for workers. And so the queens are receiving 2 to 3 times more food than the workers. And so based on this more food, they have more resources available. They can grow larger, grow these ovaries, and then have this highly specialized sperm storage organ called the spermatheca. And so this caste determination is really important. Now, a lot of research shows that you have to graft queens by at least 3 days. After that, there's sort of a point of return where that larva is basically on the worker trajectory and cannot go onto the queen trajectory. Now, I would never graft a 3-day-old larva, and if you're taking a queen rearing course, you'll learn that because it would definitely impact the queen, and you'll have some issues with the queen. So I always try to graft larva that's less than 12 hours old if possible. And so really young larva that just hatched from the egg, and you know that these are clearly on the queen trajectory path because if you graft larva that's too old, they could have what we like to call intercaste. So half workers, half queens. So these queens will be kind of specialized for both a queen and workers. They can have smaller ovaries. They can be smaller in size. They can they have a lesser capacity to lay with more males or to store more sperm from males. And so it's really important to graft from really young larvae to produce the highest quality queen as possible. So what's in royal jelly? So I think a lot of people think that, royal jelly is only fed to queens, Worker jelly is only fed to workers, and there's a clear differences between them. But royal jelly and the jelly fed to workers and queens are essentially exactly the same. And you can sort of view royal jelly as a milk for bees. It basically has all the nutrients that the larvae need to grow and develop either into a worker or into a queen. Now, royal jelly basically has all the major macronutrients and micronutrients the bees need. So for the macronutrients, it has all these important proteins, about 6 different proteins called royal jelly proteins that are important for growth and development. They have different types of sugars. So mostly glucose, but a little bit of fructose in this royal jelly. And typically what we see is we see more sugars in the worker diet, whereas more proteins in the queen diet. But really the differences are pretty marginal. Water, obviously the big source, and the lipids, which are the fats. And then there's a lot of micronutrients. And so what happens is some of the micronutrients like antioxidants, vitamins, minerals are collected from the pollen and then transferred directly into the royal jelly. And so, has any of you ever tried royal jelly before? If you have, it's really bitter. I actually don't mind it. I think a lot of people don't like royal jelly, but I really don't mind the taste at all. But if you have the chance to raise your own queens or buy royal jelly, the best royal jelly to try is ones that is fresh from the colony versus the one that's frozen from a store. But yeah, it has kind of a different bittery taste, but I really don't mind the flavor of it. So one thing I did at through my master's degree at North Dakota State University was I was really curious what made a queen versus not a queen. And so one thing we did was we did this method called in vitro grafting. So that means we were basically artificially raising these larvae in an incubator. And so that allowed us to control what was fed and the quality of food that was fed to the young larvae. So I had these 24 cell Petri dishes. So basically each cell is kind of an opening. And I added royal jelly and a mixture of sugar and micronutrients and then fed the larva. And then each day actually had to go back and feed the larva every single day so they had fresh food. So I was basically the worker bee. It takes a lot of time, but it's I mean we had a pretty good success rate. You can get 90% of the workers and queens to be raised in these incubators. So we fed them about I won't go into this too much depth, but we fed them different quantities. So worker diet versus the queen diet, and saw, was it the quality of the food? So was there a difference between royal jelly and worker jelly, or was it the quantity of food? And then we basically got the queens and measured, I guess, how queen-like are they? Are they more queen-like or less queen-like? Because if you actually compare the morphometrics, the head and the legs and the mandibles between queens and workers, there's differences between them. And basically what we found is this is the best picture. I've learned that taking pictures is really important for these talks. It's pretty blurry. I guess it was like 20 years ago now. So, oh, not 20, like 15 years ago. But yeah, this is the queen this is a larva that was fed in the queen diet. So you see it's pretty large. It has the head, has a huge abdomen, so it looks just like a queen. This was the worker fed on the worker diet, so typically a worker. But the interesting thing is, if you change the amount of food that's provided to the queen, they became what we like to call intercaste. So these are basically half workers, half queens. And so as you fed them more food, it became more and more queen-like. But even in this situation, this has some features like a worker, but also some features like a queen. So they're kind of in between both of them. We're also able to raise, workers that were half the size of a normal worker. So, I think a lot of people um, view bees as either they become a queen or either become a worker, but there's actually like a big range that they can become. And the workers are just really great at controlling whether they become a queen or worker. But if there's issues in your grafting or your emergency queen cells and they're raising really old larvae, these larvae could potentially become these intercasts or half workers, half queens. And so that's one reason I'd never recommend raising larvae or raising queens from really old larvae, 2 to 3 days old. Because if you do, they're already partially on that worker trajectory, and they can become sort of these intercasts or half workers, half queens, and they'll be lower quality altogether. So they have smaller ovaries, they have a smaller spermatheca, so their ability to mate and store sperm is less, and they just have features for a worker that's not necessarily needed for a queen. And so that's why it's really important to raise really young larvae who don't have this situation. And one thing I do typically see with some emergency queen cells or even some with walkaway splits is the bees are basically forced to raise queens on what they have. And so if the larvae are what they have and they're really old, your colony could be raising a queen, but they could be these kind of half queen, half worker intercasts. And so it's really important to have young larvae and even eggs is the best case scenario. So you make sure that your colony is raising the biggest and highest quality queens as possible. So these are different queen cells, and like I said, in my opinion, the swarm cells produce the highest quality queens. They're typically larger, have larger ovaries. That's not to say there's anything wrong with supersedure cells. I just see better queens coming from these swarm cells, and so that's one reason when I raise my queens, I use swarm boxes. So I make an artificial swarm and then raise queens that way because they're really amped up. They have the resources and young bees to raise more queens, and so to me, this is the best case scenario for raising queens. But for supersedure cells, a lot of times you have less brood in the colony, the queen's starting to fail, your workers may be getting on the older side, so they're less vigorous and willing to raise a new queen. So, it's not to say that supersedure cells produce, crappy queens. Just in my opinion, they're not as high quality as swarm cells. But the issues you have with some of these intercasts are pardon me, these emergency queen cells. And so, like I said, if your queen accidentally dies and there's really old larvae in the colony, the workers are basically forced to raise queens from those older larvae. And so, in that situation, you could have smaller queens or maybe these intercast type queens. And so, these emergency queen cells, you'd be really, really careful about how you raise them because typically they're actually a lot smaller. So, you compare these emergency queen cells to swarm cells, they're typically a lot smaller. And really the size doesn't always mean that they're higher or lower quality queens, but we do know that typically if they're a little bit longer, that they're probably gonna be larger, higher quality queens. I think there's a question from Autumn. Need a hand raised. Okay, yeah. If you want to ask a question, just jump in the chat or yeah, just speak. You can unmute yourself. So yeah, this all means that larva age matters, and so once we get to the queen ring section, we'll talk a lot more about how to choose the right larva for grafting. And as a new beekeeper, the first time you start grafting, it can be kind of hard to find the right stage larva, so you might want to cage the queen so you have them of a known age. And so, especially for new beekeepers, what I typically recommend is to cage a queen on Monday, and then you can graft on Friday because they'll be right around that 12-day old period. And so these are different ages, right? We like to call them, ages or instars. This is an egg right here. We have some kind of first instar right here. You can barely see the larva. This is the best age to graft. You want to graft when they're less than about somewhere between 12 and 24 hours, because they have a lot of jelly and they're easy to graft and move. But you don't want to graft larvae at this old, at this 3 days old, because if you do, they may raise a queen. Your acceptance might be pretty low, but they may raise a queen on this, and they might be that kind of half worker, half queen intercast. So you want to try to make sure you choose the right workers. But even if you're doing a walkaway split or if you're doing any type of raising queens, you want to make sure you have enough young larvae available in the colony for them to raise future queens. Okay, so we talked a lot about kind of development, but mating is really important for queens. So, queens simply fly out and go to these areas known as drone congregation areas, and they basically go there because that's where the drones are congregating to, and so they know it's really a really great way for the queens and drones to find each other. And so, if queens and drones are just randomly flying in the air, they might never run into each other, and the queen might not have the potential to mate with as many drones as possible. And so, these DCAs are a really great way for the queens and drones to find each other. And so we're still not quite sure why they choose these specific mating locations. We do know that the drone produces a very specific pheromone that could be sort of a trail pheromone that the queen follows to find DCAs. Maybe they're both using landscape cues to find DCAs, but we're still learning more. But what happens is the queens enter these DCAs, and the drones are forming these massive drone comets and chase after the queen. The queen will mate with somewhere between 15 to 20 males, sometimes more, sometimes less, just kind of depending on the weather. Um, and then she'll store that sperm in the spermatheca, which is right here. And then once she's done mating, basically every time the egg goes through the oviduct, it gets fertilized by a sperm from the spermatheca, and then they're able to lay future workers, maybe even a future queen. Now with mating, it's really weather dependent, and so I know a lot of, especially commercial queen producers here in Texas, they always start raising queens right on Valentine's Day, like April 14th or April 14th, February 14th, February 15th. Now, the problem with that is weather's pretty variable, so the weather conditions might not be ideal for queen mating. There may be less drones available. And so, raising queens early on can be really risky in a lot of different ways. And so, what we typically see when queens are mated, early in the spring, like February, early in March, we see that queens are mating with maybe six males versus maybe the 20 that they need. And so, if you do decide to raise males or raise queens, you want to make sure that there's as many drones available during the mating process. And so, this is something that also can say with your nooks or your splits is to time this out really properly. And so kind of like we talked about during the last section, really a really great time to start raising or making your splits is probably, early April to mid-April because you have a lot of drones around. And so you have more mating availability. The weather is more favorable, so you don't have weather issues with your queen mating, and so you might have a better success that way. Now, that's not to say that your queen success might be less in March. It just means that you have more risk there. So here, I guess last week we talked about the different subspecies and different subspecies have different number of males they mate with. Now remember that most of our bees here in the U.S. are basically mutts of the different subspecies, and so if you actually go to the native ranges like Asia, Europe, and Africa, and you sample those bees, they have different mating frequencies. And so this is the number of males that they mate with. So, Apis mellifera capensis, which is the Cape bee in South Africa, they mate with about 25 males. Apis mellifera carnica or the Carniola honeybees, they mate with about 15. Ivarensis, which is kind of a Middle Eastern bee, mates with 19. Lagustica, which is the Italian honeybee, mates with an average of 7, so not as many. The German honeybee, 11. Monticola, which is basically Northern Africa, 9. And then we have, yeah, like feral European honeybee about 6, and then Scutellata, which is African honeybee about 19. So I mean, this is so that I mean, there's a lot of variation. I mean, it ranges all the way from 6 all the way to over 25. And so this can be true about the queens that you get or the nooks or packages that you buy that if buying queen cells or raising your queens, there could be differences in the number of males that these queens are mating with. And so it's not to say that if your queens only mate with 6 that they're less quality, but it means that if your queens are mating with more males, there's gonna be more genetic diversity within your colony, and they have a better ability to combat some of the diseases and issues that your colonies may face. So I know I show this video again, but I always like this video to kind of show the mating behavior to some extent. And so this is a queen that's kind of flying out. So she's a virgin queen that just emerged, and now it's time to go out and mate and find some males. So they're going to the DCA, and you see a bunch of males are kind of clustering and forming this drone comet. They chase after the queen, and you can imagine these 25,000 males competing with one queen, how competitive that environment is. So they're kind of knocking each other out of the way. One lucky drone that's fast enough and catches up to the queen latches on and then starts disseminating the queen. They actually become paralyzed. So you can see their wings stop and they become paralyzed midair. And then they fall a few feet down. And then eventually that drone disseminates the queen. And then that drone dies and never gets to mate again. But then this queen will fly out and basically go out and mate with more males. I'm gonna stop it right here. So this is the mating plug. And so after the mating process, the mating plug is inside the queen. So if the queen decides to go out on multiple mating flights, she'll go back and remove this mating plug. Sometimes it'll actually naturally fall out. But sometimes if she goes back to the colony, the workers will help her kind of pull that out because if that's in there, that's one way for some of the males to make sure that their brothers or other competitors are unable to mate with the queen. And so we actually know with bumblebees, for example, they have this kind of glue mating plug. And so that allows only that one male to mate with that queen, and it stops other males from mating with that queen. But honeybees have a better ability to remove that plug so the queens can mate with more males. So what does mating number depend on? It depends on, I mean, really a lot with weather. And so you can raise a really good queen. It's really hard to predict what the weather's going to be like in 2 to 3 weeks. And so weather can be all over the place, but it really has a big influence on the number of males queens mate with. Now just remember if you have some rainy days here or there that the queen probably not gonna go on mating flights, and she'll probably wait a couple of days to go on mating flights, so she'll try to mate with as many males as possible. But if you have kind of a few days or even a week of really poor weather, that could drop your queen mating frequency from 20 all the way down to 6. And so weather plays a really big role. So you want to make sure you try to raise queens when weather is more predictable. We have different pathogens and parasites, and so Varroa and pathogens like viruses play a big role. And so we know that if queens and colonies have more viruses, that can directly impact the number of mating. Nutrition and pesticides and virucides like miticides also play a really big role. I know like Juliana and Dr. Liz Walsh, they did some really great research showing that if queens are really stressed out or the colony is really stressed out, the queen actually mates more often. And so they found that if you apply an insecticide to a queen cell, that the queens will increase their mating frequency from I think like 20 all the way up to around 30 or 40. And so that could be one way for the colony to combat some of these stressors, to mate with more males, increase the genetic diversity within the colony to deal with some of these issues. Now, that's not to say that you should be, pouring insecticides on your colony. It just means that's one way for the bees to combat it, but they're still going to be stressed out from it. Okay, now we get into egg laying. So we talked about, the overdevelopment and caste termination. Then we got into mating behavior. Now we get into the egg laying. So a healthy queen can lay upwards to, 15 to 2,000 eggs per day. But like I mentioned earlier, there's a lot of variation in the egg laying rate. So some lines and some queens produce or lay more eggs per day. Some lines, lay less eggs per day. So I know some lines maybe only lay 1,000 eggs per day, whereas some can lay upwards of 3,000. So, 2,000 is just kind of like a broad average that we always say and use. And I will say a lot of times it kind of varies on the year and the resources. And so if there's less resources available and you're during a pollen dearth, the queen's gonna lay less eggs because she has less resources available to lay these eggs. So we always say, 1,500 to 2,000 is the average, but there's a lot of variation because it depends on the season, depends on the resources, depends on the environment. But this is what a mated queen looks like. So once she's fully mated, this is spermatheca, which is right here. And as you see, it's sort of this kind of white crystal ball. So it's filled with the sperm that she's going to use during fertilization. And this example of an unmated queen. Now, if you decide to raise your own queens, you can kind of partially tell how well mated the queen is. We actually have a lab here. We can, pull out the sperm and see how high quality the sperm actually is. But if you're raising a lot of queens and you don't mind risk seeing what she looks like, or maybe you're doing your split and you want to see what that queen that you're planning on killing looks like, you can basically dissect the spermatheca out and take a look at it. But we'll say that she within this kind of crystal ball of the spermatheca, she produces very specific antioxidants and proteins that help protect the sperm. And so as the queen gets older or experiences a lot of different stressors, that can really impact her ability to store that sperm for longer periods of time. And so typically with older queens, um, they're they're producing less of the antioxidants and they have a worse ability to keep these sperm alive. And so it's really important to, kind of see the signs of queen failure and replace the queens appropriately. So how do you identify a high quality queen? So I know I talked about this a couple weeks ago, but I think it's really important to know the signs of a good quality queen versus a low quality queen or potentially a failing queen. So when I say failing queen, a queen that's probably about to be replaced or queen that's running out of sperm and unable to lay as many eggs as per day that's needed to sustain the colony size, sustain the colony growth, and really reduce mortality of that colony. So when I look in the colony, the first thing I always look for is the brood pattern. So, brood pattern isn't always the best indicator. There's a lot of things that can play a role in brood pattern, but brood pattern can be a really great first sign to see how well your queen's doing. And so if I see a brood pattern like this, and I typically have a scale from 1 to 5, if I see a very solid brood pattern, maybe a few open spots, to me this is a sign of a really great queen. She's not missing many spots. She's laying as many cells as possible. And so for me, this is a really great queen. Whereas if you start seeing a really spotty brood pattern like this, and she starting to lay drones in the middle of the brood frame along with workers, that's a sign that she's running out of sperm and starting to lay these kind of males or unfertilized eggs. Now, this is not to say that, I mean, all bees and all queens will start laying drones at some point. But if you kind of open up your brood box and look at the middle two frames, and you start seeing a lot of these drone comb interspersed with the worker comb, that's a really great sign that your queen's starting to fail, started running out of that sperm, and you might want to think about replacing that queen before it gets too late. Because if the queen fully runs out of sperm and she's unable to lay future worker eggs, then that colony has a situation where it could become hopelessly queenless and unable to raise queens. Could also become like a laying worker colony and get to a point of no return. So if you start seeing something like this, you want to take action as soon as possible. So once I see a colony like that, one thing I'll typically do is do kind of a larger inspection to the colony and try to find the queen because I want to see what the queen looks like. So this example, what a healthy queen looks like. So you can see that she has hair under thorax, her wings are fully intact, and I don't have a video here, but the workers really love this queen. So they're taking care of her, grooming her, and making sure that, she's really taken care of overall. But this is an example of a failing queen. So you can see her wings are really tattered, especially for this wing, this left wing. But this right wing, you can see its wings pretty much half torn off. And if I had a video here, the workers were actually chewing at her and biting at her, and you're basically saying that, hey, you're not a good queen. We might try to replace you. And so you can see the kind of this biting behavior on these old failing queens. And this queen was actually the same queen from this colony. So, I can obviously see from this frame that this queen's failing. But if you take a close look at the queen, you can see that the workers also sense that, and they want to try to replace her as soon as possible because they really don't want to become hopelessly queenless, and they also don't want to become a laying worker colony. Next thing I always look at is the retinue. So similar to brood pattern, the retinue is not always the best metric for looking at your high quality queen, but it's a good way to see how well the workers are treating the queen and how well the workers are taking care of the queen. And so, like I mentioned in the last slide, if the workers don't like the queen, they'll definitely tell you and you'll see the signs. They'll start biting at her, they'll start kind of chasing and pushing her. And so the workers can really tell you a lot about how they think about that queen. But we see a really clear retinue and attendance of workers around the queen. So they're kind of grooming her, they're feeding her, they're taking care of her, and there's a lot of workers constantly surrounding the queen. That's a really great sign that the workers like the queen. But if you see a situation like this, where there's no retinue and there's not a lot of attendance workers surrounding the queen, maybe they're biting at her, pushing her, that's a sign of a lower quality queen and that they might want to replace that queen. Now, retinue can be kind of a tough metric because if you oversmoke the colony, for example, the bees tend to disperse. If you have a really aggressive colony, then the bees will disperse when you open them up. Or if it takes you a long time to find the queen, so maybe you go through your entire colony, eventually find the queen on the last frame, she'll be kind of running around the colony and you won't see the retinue. And so it's always the best metric, but let's say you smoke the colony a few times, you open it up in the first couple of frames, you find the queen. That's the best time to look for the retinue. And the next thing I look for are the queen cells. So if you start seeing queen cells, that's a sign of either there's no queen in the colony, either they're trying to replace that queen, or either they're trying to make a new queen to swarm and really find a new home. So if you start seeing emergency queen cells like this, where you see a bunch of queen cells in the middle of the frame, you may see a lot of nectar surrounding it because they really know that they need more resources to help this new queen, but they also don't have any new larvae or eggs being raised. They'll start storing a lot of nectar in these cells. But this is an example of emergency queen cells. So maybe that's a situation where you accidentally kill that queen. You might see a situation similar to this if you make a walkaway split because you kind of remove that queen, that stresses the colony, and they start rapidly raising, queen cells as fast as possible. This example of supersedure cells, so a situation where the colony is trying to replace that queen. And so in this situation, you'll still see an active laying queen in the colony. You'll still see some eggs within the colony, but you'll see maybe, 1 to 5 of these supersedure cells. In this situation that once these queen cells emerge, eventually that old queen will be replaced. In swarm cells, this situation where your colony is really large, and about to swarm. I know I talked a lot about that nauseum during the last hour. We start seeing swarm cells. This is a really great sign that your colony is about to swarm. Or if they're open, that's a sign that maybe they've already swarmed already. And so this situation, you might want to do an emergency split as soon as possible. Another thing I look at is any brood diseases. And so we know that, I guess the queen has a huge influence on a lot of these brood diseases. So one, some queens and their genetics, they're more likely to have a lot of these brood diseases and other pathogens. And two, the older the queen, the more likely they are to have some of these diseases. And so we know if you have a young, vibrant, young queen, that she'll lay a lot more eggs and she'll have less of these, pathogens and disease within the colony. And so one thing I always look at is kind of the actual larva in the brood. And so if the brood are kind of this kind of C shape, this white glistening color, that's a good sign of really high quality brood. But you start seeing kind of discoloration in the brood, you start seeing some scaling, maybe you see some other brood issues that don't look normal versus this. That's a good sign that you may want to replace your queen. Because sometimes if you replace a queen with a younger queen, this disease will often clear up because either it's the genetics or the younger the queen, this can clear up really quickly. So That's one thing I do recommend. So instead of resorting to like antibiotics, certain treatments, you can simply requeen and clear up some of these issues. Now, this issue, I mean, this was pretty advanced. I'm not sure if you can do much about this, but you could do a queen and try to salvage that colony. Okay, so we can't talk about queens without talking about the drones because the queens are mating with these drones, they're storing that sperm, and they use that sperm to lay these future workers. And so drones are extremely important for the colony. And I think a lot of beekeepers forget about the drones, but I want you to know that drones are important, even though they sort of seem like mooches within the colonies. And so we have the major reasons probably the colony genetics. And so last week we talked about genetics within the colony that, part of the genetics are from the worker from the queen, part of the genetics are from the drones. And so we think about all these traits we're interested in as beekeepers, as I talked about in the queen section, they're largely influenced by the queen, but also the males. But the reason we don't think about the males as much is because we can't opt to control the males that the queen's mating with. I know for us here in Overton, we're doing a lot of insemination and closed breeding. So we're actually collecting semen from drones and inseminating the queens that we want. So that's one way that we can control the genetics of our breeder queens. But a lot of times for most beekeepers, if you're raising queens, your queens are flying out and mating with these random drones. So it's really hard to control it. But just know that depending on the drones that your queen mates with, that's going to influence the aggression of your colony, the honey production, the resilience, the heat tolerance, everything related to your colony. Then we have sperm production. So, drones have a lot of variation in the quality and the number of sperm that they actually produce. Now, once again, this is something you typically can't control, but one thing you want to do is you want your queens to mate with as many and as high quality drones as possible. And that's one reason that it may make sense to push back your splitting, your queen rearing to later in the season, maybe, late March to early April, because you may have more drones, more mature drones available for this mating process. And like I said, drones typically reach their maturity probably around 14 to 21 days post-emergence. And so if you put a drone frame into a colony, it takes 24 days for that drone to become an adult, and then it takes another 21 days for them to become mature. And so it takes at least like a month, month and a half for those drones to actually reach sexual maturity. Now, I mean, even if you're raising drones, you can't control who your queen mates with, so you can produce as many drones as possible. But if you're trying to flood your areas with drones, trying to kind of time it out with the age could be really important. And then kind of, colony traits, we go back and forth between genetics and traits to kind of go, interchangeably because if your colony has better genetics from the drones, they'll have all these desirable traits that you want as a beekeeper. And then finally, queen quality. So, queens have to store that sperm for, multiple years. And so the queens have ability to help keep that sperm alive, keep it viable, and keep it ready to fertilize the eggs. But if the drones are producing really crappy sperm or low quality sperm and they're mating with queens, then there's only so much a queen can do to keep that sperm alive. And so the queens are mating with a lot of these really poor quality males that can directly impact your queen quality, your brood pattern, and how well your queen lives and whether she fails or not. So once again, here's kind of a typical life cycle of a drone, which was kind of tied nicely into, when you plan on doing your queen rearing and when we get into the queen rearing section. So, queens take 16 days to develop, whereas drones take 24 days. So they take an additional 24 days to develop. Now, this stage is really important for sperm production, and so sperm is only produced during a really short 2 to 3 day window during this developmental stage. And so after that, drones can never produce sperm ever again. And so that's why it's really important to kind of monitor your mites because, as an experienced beekeeper, one thing you'll notice is drone broods are basically mite magnets. And so if you open up a lot of drone brood and you have a lot of mites in your colony, you'll see a lot of mites feeding on the fat body. And what can that do to the drones? It can cause fertility issues, it can cause sterilization, and it causes these drones to be really effectively duds. So it's really important to control your mite population because they can have the hugest and most impact on the drones during sperm production. But even if you're using certain miticides, so synthetic miticides, or using other things, these can directly impact male fertility. Once these drones emerge as adults, they have to reach sexual maturity. And so that takes about 10 to 14 days for them to actually mature. So typically these are the young drones where they're really fuzzy. They almost like look like they have skin on their eyes. And they're typically in the middle of the brood box where the young nurse bees are. And so your colonies are probably producing drones now, if not probably pretty soon. And if you go into your colony during your inspection and you pull out the middle two brood frames, you see drones, and they're really fuzzy. These are really young drones, and they're trying to reach sexual maturity. And oftentimes they're being fed and taken care of by the workers because the workers are helping them reach that maturity. After the drones reach sexual maturity, they get moved to where the honey is stored. So they're either moving to the outskirts of the frame where the honey is stored or up into the honey supers if you have them on your colonies. And they're doing that because they're switching from a high protein diet provided directly from the workers to a high sugar diet that's in the honey supers or wherever the honey and the sugar is stored. And they do that because they're switching from a high sugar diet that they need to go on these multiple mating flights. So they'll be flying for, maybe 6 to 10 flights per day. These flights can range for 20 to 40 minutes. And sometimes they can be, flying in, extreme weather conditions like extreme heat conditions. So they definitely need a lot of sugar and so that energizing nutrients to make it to these mating areas and find a queen. So the drones only have one chance to mate, and if they mate with a queen, then they die after that. But they don't. They basically die trying to find a queen. And so this mating process will basically occur until either the drones mate with a queen or they die trying. Now, typical drones will live maybe 30 days max after they emerge as adults. So the whole lifespan of a drone is probably around 34 to 50 days. So this is the development of a drone. So this is the fifth instar larva. So this is when larvae reach about 5 days old. It's almost like I mean, the larvae are really big. It's almost like they're overflowing out of the cell. That's how you know it's a fifth instar larva. And if you look at this larva, this is when they actually begin producing sperm. So this is a really important stage for sperm production. Now, within a day afterwards, this cell becomes capped. This larva becomes upright and starts spinning cocoon into what we like to call a prepupa stage. And this is the second stage of sperm production. So sperm is only produced during this really short 2 to 3 day window, and after that, drones can never produce sperm ever again. And so this stage is really sensitive and really important for your drone quality. For sperm maturation, this is when the sperm tails are formed, and this allows the sperm to physically swim from the testes to the organ that's used to transfer the sperm from the drones to the queens. So this is a so sexual maturity is yeah basically when the workers are taking care of the drones, but the workers are basically helping the drones and their sperm migrate from the testes where the sperm is produced into the seminal vesicle. So I talked a lot about this during anatomy, so I want to kind of a quick refresher, but the sperm has to physically be in the seminal vesicle in order for that to be transferred into the queen. And so if the sperm is only in the testes, then the sperm can be transferred to the queen, so it has to physically migrate. And so for example, if something happens to the drone, so let's say they produce 4 million sperm cells, but only 1 million actually kind of move to the seminal vesicle, that means they can only, transfer 1 million sperm cells to the queen, even though they actually produce 4 million. And so the workers are really trying to help frantically provide as many resources, warmth, everything that drones need to help that sperm migrate and as much sperm migrate as possible. Now, one quick way to see if your drones are mature or not is by simply popping the drones. And so you guys probably have a few drones in your colonies. And what I would do is I would take a drone, squeeze their thorax, and this organ called the endophallus will pop up. And you can tell whether your drones are mature or immature. Um, we actually did this, I think Thursday or so, and most of our drones were mature or immature. I think we had a few that were mature, but they're about a week behind, at least in our area. But this is a really good way to know whether your drones are ready to mate with the queen and have the sperm available. So this example of a mature drone, you can see the endophallus is fully popped out. You have the sperm at the tip of the endophallus, and this drone actually produced a lot of sperm. So this is a really high quality drone. Whereas this example of an immature drone, you can see that its endophallus is clear. There's no brown sperm at the tip of endophallus, so this drone is immature. So if you go out to your colonies doing inspections over the next couple weeks or month, just pop a few drones and see if they're mature or not. Their mating behavior, so basically the drones form these massive drone comets that have somewhere between 100 to 25,000 drones. Once a queen arrives, these drones chase after the queen, and lucky 15 to 20 will mate with the queen. So we're still learning more about these DCAs, but we're seeing that the drones use certain pheromones or pheromone trails to find these DCAs. I'm assuming that queens maybe use those same pheromone trails to find the males because you have to have a way for the queens and drones to find each other. So it could be partially landscape, but it could also be partially these pheromones that the drones are producing to not only attract other males to congregate in an area, but also attract the queens to fly to those areas. So we're still learning more and more about these DCAs and how they form. But it's a really great way for the queens and drones to find each other, and more importantly, for the queen to mate with 12 to 20 males. So one thing we're doing at our bee lab here is using radio tracking to find these DCAs. If you talk to any old-timey beekeeper, most will say they've never seen a DCA before. If they have, maybe they've seen one a long time ago. I mean, even for the people that have been keeping bees for, decades now, most have never seen a DCA before. So if you've never seen one, don't worry. They're really hard to find. I've only seen a few in my life, and it's just because they're so hard to find. So this was a study done in Puerto Rico, and you can see these different triangles are where they actually added these radio tracking devices on the back of the drones, and they're able to track where the drones are flying. So they were able to see how fast the drones are flying, where they're flying to, and where these potential mating locations were. And so even though they tracked maybe 30 to 40 of these DCAs or 30 to 40 of these apiary locations, the drones were only going to maybe 4 to 5 of these DCAs. And so, but one thing that they found really interesting was the drones kind of go on these orientation flights. So instead of going back and forth between one DCA, they actually go to multiple DCAs, and then they're sort of trying to find I guess, the sexiest bar. And then after that, they go back and forth, which is one DCA. So once they get older and they know they have to mate as soon as possible or they'll die without mating, they tend to go back and forth between one. But the really young drones tend to go to multiple DCAs. And so one thing we want to do is to track drones and find DCAs across Texas to see where DCAs are and how they form in maybe West Texas versus East Texas. So, I mean, we can really identify practical solutions for beekeepers. So, one, how can you flood these areas with your drones, and how can you make sure you have the highest quality drones as possible? So one thing we want to do is once you find the DCAs, working with clubs across Texas, we're going to fly a drone over the apiary location, and our plan is to produce a very specific 3D map of that drone congregation area because you want to see if we can find a really easy, quick way for beekeepers to find DCAs. And so once we fly this drone over an apiary location, we'll produce this very specific 3D map. And this 3D map is really high quality. It has like a one millimeter quality. So we can actually zoom into the forest, we can map underneath the forest. And so but what this will tell us is if there's a DCA right here, we can say, okay, this DCA is next to this forest edge. And so, if we fly over your apiary, we can say, okay, the DCAs are more likely to be here versus here. It'll make it easier for beekeepers and queen producers to find DCAs. And so we're hoping to do this across Texas. We'd love to work with a few clubs and local beekeepers. I know Dodie plans on doing this for her Master Craftsman project, so we like to work with as many beekeepers as possible to find the DCAs. Once these find DCAs, we'll do a 3D map around that location to really identify what causes a DCA and how to find DCAs easier. And then next, you want to understand where drones go and which DCAs drones go to. So what we're going to do is, once you find DCAs, once you map DCAs, we're going to collect drones from those drone congregation areas and then see where the drones came from. So we'll collect them, do genetic testing and see, okay, maybe drones from, colony 2 went to DCA 1. Maybe drones from colony 3 went to DCA 2 and so on. And so this gives a better idea. So maybe drones from certain colonies go to one DCA, or maybe it's just random. Who knows? But it's a good way to learn more about how these mating areas form, how queens and drones find each other, and what practically beekeepers can do to not only flood those areas with drones, but maybe have some sort of controlled breeding without using insemination. So yeah, I mean, just with drone, I mean, you have sperm production during development, which is really important, their ability to reach sex maturity, and the ability to find and mate with a queen. So what are things that can impact drone and queen quality? So most of these things are pretty similar across drones and queens. And so we know that these honeybees forage in 3 to 4 mile radius. They're exposed to all these different environmental variables. And so a lot of different things can impact the drone and queen quality. So mainly, especially with mating, especially with queens, weather plays a really important role. So if it's really windy, if it's raining, if it's really cold, that can impact how many queen or how many drones a queen mates with. But can also impact the drone mating behavior and their ability to find these DCAs. We do have pathogens and parasites. They all play a really important role. So if you have more pathogens and viruses within your colony, that can impact, drone and queen quality and even mating behavior. Pesticides can play a really big role. So you think about the 3 different types of pesticides. We have, the insecticides, fungicides, and herbicides. And if those get into the colony, whether directly or indirectly, that can directly impact the queen quality, queen mating success, and may eventually lead to queen failure. Then we have nutrition. So when there's a lack of pollen or other resources that can directly impact, queen quality, and then miticides. So what beekeepers are applying to colonies. So all these different factors play a really important role and can directly impact the drone and queen quality. And then just genetics, right? We talked a lot about genetics last week, so I won't talk about this too much more. But our bees are basically mutts, but your bees could have more Africanized genetics or more, European genetics, and so it kind of depends on where you're buying your bees or how you're grafting your bees. And so the genetics can play a really big role. And so as I talked about the mating number, if you're certain genetics within your queen, then they can mate with more or less drones, or certain genetics could lead to queens that live longer or maybe with more males, so things like that. So genetics play a really big role. And so that's why it could be important for you, especially if you want to try out different lines. Buy queens from different sources, try them out, and see which one performs best for you. I'll kind of briefly talk about requeening and queen introduction. I know I talked a lot about this during splitting, but there's different ways to introduce a new queen if you need to. So let's say your queen is failing and having issues, like what things should you be doing to replace that queen and add a new queen in the colony? So you can either do kind of a walkaway split or a walkaway situation, but the problem with doing that for a failing queen is you might not have the right age larva. And so in that situation, you might want to add a frame of young eggs or eggs and young larvae to that colony so they have something to raise a high quality queen from. But really the biggest benefit is there's no cost involved. You're raising your own queens and you have to pay for either a queen cell or a mated queen. You're using your own stock, so you're making sure you're basically grafting from that colony with that known genetics. But one issue is more mating time. So, I mean, it takes 16 days for the queen to develop, another, 10 days for the queen to properly mate and begin laying eggs. So it can be a really time-consuming process. And sometimes the success rate can be a lot lower. Queen cells are a really great option, especially here in Texas. There's a lot of major queen producers, whether locally or even parts of Texas, like East Texas, that raise queen cells for very cheap. So, we can typically buy queen cells for about $6, so it's not that cost effective. And for these professionals that they're doing a really great job of raising queens. They're making sure the queens are as high quality as possible, and these queens are going to probably live as long as possible. So, there are some problems with doing walkaway splits or having the colony raise their own queen. And so by grafting and getting queen cells, that's one way to make sure the queens are as high quality as possible. But also one benefit of queen cells is you can ensure local mating. So, you're getting the queen genetics from the queen producer, but your queens are going to be mating with drones that are local to your area. So they might be more locally adapted and resilient to your certain part of Texas. One downside is they just need more mating time, but you typically get them at, 12 days or 14 days right before emergence. So they'll probably mate within another couple weeks. So, it's not as long as a walkaway split or having them raise their own queen cells, but it does take a bit more time for that queen to actively lay. Now, mating queens, I think there's some benefits, but then a lot of downsides for using mated queens. One of the major benefits is they start laying right away. So they have instant egg laying, so you can really add that to a colony, and then that colony can begin growing and reproducing right after. I say sometimes they're reliable. It kind of depends on where you buy your queens. It can be difficult to have queens that are shipped across the country, so there's a lot of stressors involved with that. Sometimes the introduction can be a bit trickier if you're not experienced, and so. But once they're established, they're pretty reliable because they already made it, and you know that they already made it properly. But they also tend to be more expensive. So some can be over $40 a queen, so they can be more expensive than buying a queen cell or having you raise your own queen. So queen introduction. So one thing is if you buy a mated queen is use these kind of wooden queen cells. There's different types of methods like the three hole queen cells, but they're essentially exactly the same. So one benefit is they have known genetics, and so you know where they come from. So if you're buying an Italian queen or Carniolan queen, you know they're coming from sort of a reputable source. They can help like a queenless or weak colony or even a recent split or nook. They increase reproductive success. So if you have a weak or queenless colony, you can help that colony get a new queen and help that colony grow and really survive into the year. But really, the major downside is the cost. One method is to do pushing cages. So if you want your queen to begin laying eggs right away, you can add a pushing cage. So one downside of this is the queen's restricted to the area, so she's unable to lay eggs right away. But I will say, like once you move that cork from that queen cell, within probably at least 24 hours, the workers will accept her and get her into the colony. So, even though it does take a little bit of time, you can definitely look in the pushing cages if you want. So if you buy mated queen, you can put into the pushing cage so she starts laying eggs right away, but it's really up to you. I don't think the success is any higher or lower. Maybe some people have some other experience with pushing cages with new mated queens, but I would probably just keep in the the wooden queen cage if possible. And I guess I don't have a picture of a queen cell, which I should. Um, yeah, okay. So one thing with queen cells, right? You can add the queen cell right there, and the queen cell will fly and mate with your local drones. Sometimes the success can be really good. Sometimes it can be really poor depending on the weather. So there is some risk. There's definitely more risk involved with a queen cell versus a mated queen. But I think there's a lot more benefits that outweigh the cost of a queen cell. Because they're mating with local drones. Maybe you're grafting from your own colony, so you know about the queen genetics, and so there's a lot of benefits for using queen cells, I think. And also the cost is a major benefit because they can be a lot cheaper. So either you're making them yourself or you're buying them from a queen producer. So one thing you can do during queen cell introduction, so I typically just put queen cells directly into the colony, but if you want to kind of cage them so they don't get damaged, you could definitely put them into some of these different virgin queen cell cages. There's a lot of different options that you can buy at any type of bee supply store. If you have a 3D printer, these are pretty easy to print, and there's a lot of free, I guess 3D models that you can use online. So, but these are different cages you can put the queen cell into. The queen cell will emerge, and then once she emerges, you can basically let that queen emerge or basically open up that cell and that queen will go back in the colony because the workers will get that scent right away and they'll accept that queen right away. Okay. So I think we have, a few times for questions, but next week we'll talk about extracting, bottling, and selling honey. And so I decided to push the queen rearing and breeding section to 2 weeks from now. I guess I know it made more sense to have it, next week, but I'm going to push it back a couple more weeks for now. So it gives us some time to get all of information ready. But if you guys have any questions, I'm happy to answer anything. So D2, I've never split, but I'm going to attempt when highs become more abundant. Yeah, that's great. Yeah, let me know how everything goes. Why the differences and oh yeah, okay, I'll go back down to the bottom. So Danessa says we use queen cells. I've had better success versus placing fully mated queens. Yep, I totally agree. I always push beekeepers to use queen cells. I always had good success with queen cells, so that's what I would recommend. And I've always had really great success with queen cells. I mean, there's some risk involved, but I think there's just as much risk involved as buying a mated queen, especially if they are shipped across the country. And then maybe Dodie at some point we can talk about the DCA project. So she can do that for a Master Craftsman project. So, if you guys decide to move on to the Master Craftsman level and want to do a research project, this is really the type of project that we're looking to do. So, I have an idea, but I really need beekeeper support to help me work with clubs across the state, help find these DCAs, and really help my research, but more importantly, help the beekeepers. And so I'm excited to start working with Dodie on this project. So Ski had a question. Is it true that if a queen mates with an Africanized drone, her egg her eggs fertilized with that Africanized sperm are laid first? So I'm not sure about this paper. I would say that I read a lot of research. Let me look at this paper first to see what Heather shared. Okay, I'm
Yeah,
gonna
it's
read this
pretty
whole thing.
old, Garrett. It's from like 2004.
What did they say?
There was a comment on there that if for when they inseminated and it was 50% European and 50% Africanized, that they used the Africanized sperm first. But I
Mhm.
mean, it's just, I don't
Yeah.
know if there's any more recent research on that.
Yeah, so I think I know the paper they're referring to. So I've seen a lot of mixed results, and so I've seen one paper that showed they start laying the Africanized eggs first, or the Africanized fertilized eggs first, and other ones where it didn't matter at all. And so it's been kind of all over the place. So I think it's pretty mixed up for the most part. I mean, we really don't know what's laid first, but I've seen some research showing it does, some research showing it doesn't. But I really think that's really mixed up really well, and that there's not preference for certain sperm versus other ones early in the season versus late in the season.
Yeah,
But
and
I
see,
mean,
that's what I had thought in
yeah,
my head is there was no preference, but
no.
do emerge first though, right? Before the European lineage,
Um,
or is that
it,
not set?
I
Is that not known either?
I don't think so. I'd look into that, but even if they do, it's probably not gonna be that much earlier. I think their development is a little bit faster, but it may be only be like a few hours tops. It's not like it's a full day.
Okay.
But you think about the US, I mean, most of our bees are mutts, and so it's probably not gonna matter. So if you have more Africanized in your genetics, there's probably gonna be a difference in development or anything like that. But yeah, it'd be actually really cool to kind of inseminate a queen with Africanized genetics and see which one's laid first. So you can basically sequence workers as they're merging, and then maybe there is a preference. But I haven't seen any research that shows there is a preference. VK says if the queen dies suddenly, will the worker bees lay fertilized eggs to try make them the queen? Well, yeah. So the workers can never lay fertilized eggs. They can only lay unfertilized eggs. And so, but typically, if the queens die suddenly, the workers won't become laying workers right away. They'll try to do the best of their ability to raise a new queen. And so, if there's already kind of eggs and larvae in the colony, they'll start raising queens from those already established queen cells. Now, a situation where the colony becomes hopelessly queenless, so all the larvae kind of age out, they're unable to raise a new queen, then there's a situation where one of those workers may become a laying worker. Now, those laying workers have shriveled ovaries, and they don't have a kind of a fully developed spermatheca, so they actually can't mate and lay fertilized eggs. So what they do is they start laying a bunch of unfertilized eggs, which become males. And so that's a situation where you have a laying worker in your colony.
Oh, and there was one question you skipped. Tom, I think when you were talking about um, the different, I guess, gradient from worker to
Hmm.
queen, he was saying those um not so great queens, could they become laying workers at some point?
If the not so great queens could be laying workers,
Yeah, like your inferior quality queens, like if you have emergency cells made from 3-day-old larva or something like that.
oh yeah, yeah. So I mean they are still intercaste, right? So they won't become lane workers. Like they're kind of half workers, half queens, but they're typically kind of a bit more queen-like. And so they still have a spermatheca. They can still fly out and mate. They'll just fail at a really high rate. Now, if you have maybe ones that are more worker-like, those ones might be more likely to become lane workers. That's a really good question. I'm not quite sure. Um, but I'd probably doubt it. I mean, the ones that are more intercaste are typically more queen-like, and they still have the ability to mate and lay fertilized eggs. I think Autumn had a question at the top. Let me see if you can find it. So if you could explain the distribution of frames in terms of percentages, that might be easier. 40% capped. Oh, this must be from our last section. So please let me explain that. Was it the last question? I think it's the last question. Okay, perfect. Well, yeah, so next week we'll talk about, honey bottling and selling here in Texas. But like I said, let me just kind of put that link in the chat again if you're interested in signing up for these colony tags. Like I said, it's free. We're hoping to get these printed as soon as possible. We'll also send you a link for the hive inspection sheet. So if you guys want to use our hive inspection sheet, you can definitely use that. So please sign up if you guys are interested, and we're happy to print these tags off and personalize them to the best of our ability. So just know that we only have black printer ink, so we might have to transition your logo, whatever you want, into black, and so it might be a little bit faded, but we'll definitely try our best. Okay, perfect. Well, thank you, and we'll see you guys all next week, Tuesday from 9 to 12.